Hi there, and welcome to a Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And this is our third and final lesson in the Chapter 11 topic on sequences. And if you are just joining us now, it's great to have you here. We're going to be looking at recursive sequences today. We've already looked at arithmetic and geometric sequences at this point, and it says the final type of sequence you will work with is called a recursive sequence. A recursive sequence is a sequence that requires computation of all previous terms in order to find a sub n. So thinking back to our arithmetic and geometric sequences, if we were looking for our eighth term, we could just substitute an 8 in for n and find our eighth term. But in a recursive sequence, in order to find the eighth term, we'd have to first find the seventh, the sixth, the fifth, the fourth, the third, the second, and the first. It's going to be tedious, but this is how we do recursive sequences. Before we look at an actual recursive sequence and how we're going to determine the nth term, we're going to look at one of the most well-known sequences in mathematics, and that's the Fibonacci sequence. And the next number in the sequence is found by adding the two previous terms together. So for example, the Fibonacci sequence is 1, and then you add 1 plus 1 to get 2, then you add 1 plus 2 to get 3, you add 2 plus 3 to get 5, 3 plus 5 to get 8, 5 plus 8 to get 13, 8 plus 13 to get 21, and this would go on forever. So for example, your next term would be 13 plus 21, which is 34. So there is a recursive formula that could be used to represent this sequence. And that's to find a sub n, you take the term that's 2 places before a sub n and 1 place before a sub n, and you add them together. That's what it's saying to do right here. And it tells you that a sub 1 is 1 and a sub 2 is 1. So just given that information, you could find any term in this sequence. So for example, in order to find the sixth term of the sequence, you would substitute 6 in for n. A sub 6 is equal to a sub 6 minus 2 plus a sub 6 minus 1. And simplified, that's the sixth term would be equal to the fourth plus the fifth term, which is what you do to find the next term in a Fibonacci sequence. But if we were just given the first couple of terms of the sequence, and we were told to add the fourth and fifth term together, we don't know what the fourth and fifth term are just yet. For example, if this was a 100, we would have to find the 98 and 99th term of this sequence, but we don't know that. So you have to find every term before that to get to those terms. So a sub 3, our third term, would be equal to our first plus our second term, and we do know those because it did tell us right here that a sub 1 was 1 and a sub 2 was 1. So if we were looking for a sub 3, we would have the second term, which is 1, and the first term, which they also told us up here, was 1, and that would be 1 plus 1, that would give us 2. So using that information, we're going to find a sub 4. So using our formula for the Fibonacci sequence right here, we're just going to substitute every time we see an n with a 4. So we're going to have a sub 4 minus 2 plus a sub 4 minus 1. And we're going to have a sub 4 is equal to a sub 2 plus a sub 4 minus 1 is a sub 3. Let's see what we know. So a sub 2 we know from up above, over here, it's equal to 1. So I'm going to replace a sub 2, that whole thing, with a 1. And up here we just found that a sub 3 was equal to 2, so I can replace that with a 2, which means that a sub 4 is going to be equal to 3. Now that we know a sub 4, we can find a sub 5. So let's go ahead and substitute 5 in every time we see an n in the Fibonacci sequence formula. So we're going to have a sub 5 minus 2 plus a sub 5 minus 1, which will simplify to a sub 3 plus a sub 4. So that means a sub 5, well, we know that a sub 3 right here says it's equal to 2, plus a sub 4, we just found over here, it's equal to 3. So that means our fifth term of the sequence is going to be 2 plus 3, which is 5. Now, finally, for a sub 6, what we're going to do is we're going to do the same exact thing. A sub 6 equals a sub 6 minus 2 plus a sub 6 minus 1. That will simplify to a sub 4 plus a sub 5. And we know both of those terms now too. We know that a sub 4 is equal to 3, and we know that a sub 5 is equal to 5. So 3 plus 5 is going to give us a sixth term of 8. Now we have 1, 1, 2, 3, 5, 8 for our Fibonacci sequence. If we go back up to what our Fibonacci sequence is, it's 1, 1, 2, 3, 5, 8. It's a formula that helps us find the next term in a sequence using previous terms in that sequence. That's our introduction to recursive sequences. If this was helpful to give you an introduction or an introductory idea about what a recursive sequence is, give this video a thumbs up. If you're still not sure, now is definitely the time to press on the link for the next video to look at exercise number 2 on recursive sequences. Thanks for joining us.